In this video, I just want to play with vector valued functions, parametric equations. Um, I don't know how to emphasize enough the importance of people just playing with mathematics. Get a graphing calculator, I'm using CalcPlot 3D here, something that allows you to just do some experimenting and get some familiarity, is that a word, with these things, these curves. You haven't done them before, and the more you play with them, the more you're going to be able to actively work with them because you'll be able to recognize, hey, these kinds of equations are going to give me this kind of picture. Or if I want this kind of picture, I need these kinds of equations, right? So I'm just going to play for a little bit and show you some examples. I'm starting with your standard unit circle, x equals cos t, y equals sine t. Um, I have it plotted from minus pi to pi at the moment. Again, with these parametric equations, you can't really see the t values, right? Because you take a value of t, you calculate x and y, or if you're in 3D, x, y, and z, and you just see the x and y. You don't necessarily see where, what values of t are. So in this case, I can actually see the t value because it's listed right here each time. And yeah, and you can see where the vector is for each value of t and why we just draw the circle, right? Because the tip of that vector traces out the circle. Now, I want to just change some things up a little bit. For instance, if I change this to a cosine 2t and a sine 2t, what do I get? Well, it turns out I still get a circle. The same circle, the unit circle. Those twos didn't look like they changed anything, but they do change something. Notice as I animate now, this actually goes around the circle twice, where before it only went around once. Now, another way I can see that something has changed is by actually going into 3D here. Right, so now we got this is still in the xy plane because I have z equals 0. But I want to just say t for z equals t. And what that does now is it turns it into a helix, which is rising rather rapidly. So let me cut it down a little bit. Let's say divided by 4-ish. All right. There is something about the way this system handles that I can't quite maneuver it the way I want to. Anyway, as I animate it now, you can see that this is just tracing out that curve, but that curve is now, from minus pi to pi, it does 2 cycles, right? If I go back to the original cos t sine t, then it's only 1 cycle. So you might imagine I could get it to do more, like 4, and now it's going around 4 times. If you were just in the 2D orientation, right? If you're just looking at the x and the y and you can't see what z is doing, well, yeah, you're going around the circle 4 times in the same amount of time that it used to take, for 1 cycle. So you're moving faster around the circle, but it still looks like a circle. You wouldn't necessarily notice the difference. In 3D, we certainly do notice the difference with this thing being a helix. But one thing I've learned is that I can get more wraps, right, by just changing these numbers. So I could get, 15 wraps around here. Right? Really tight spiral. Now, another thing that I want to look at here is multiplying out front. Right? If I throw a 2 in front of the x there, that just stretched things in the x direction by a factor of 2. So rather than circles, I'm now looking at ellipses. Right? Or I could stretch the y as well. Now I have a circle of radius 2. In fact, I better zoom out a little bit here. Right? So there's that thing. Now I can also, I can do several things. I can change where the center of this circle is by just adding on something. Right? If I add +1 to the x, just moves it over 1 in the x direction. I could, let's go back to radius 1 circle. And move it out 2 in the x direction. Now, what I want to try to do is I want to try to turn this, like spin it around the y-axis here. So x and z are going to form a circle where the radius of the circle will be however far it is out to that thing. So I want to think of this now, the x coordinate, as being the radius of a circle. And so rather than this spiraling in the z direction, I'm going to put it in a circle. So I'm going to think of this as the radius of a circle in the xz plane. So I'm going to put that in parentheses and multiply that by cosine t. And then I'm going to take that same thing and put it in the z here. Only say sine t. So with respect to x and y, the cos t and the sine t are making a circle, and the multiplier out front is the radius of that circle. Well, that radius is changing as t changes, but it's the same radius for x and z. And then the y-coordinate is just going back and forth like it currently is, and that's sine 15t. So let's see what happens here. Yeah, that's what I wanted. So with respect to x and z, I'm looking pretty much straight down the y-axis now. With respect to x and z, I see a circular thing, but it keeps getting further away and closer and further away and closer. That's because my radius of my circle is a function of t, and it's going in and out like cosine of 15t, and it's centered at 2, so it goes from radius of 2 plus 1 and 2 minus 1, right? So out as far as 3 and in as close as 1. But this is pretty cool. We could put more spirals in there by, let's say 25t. You're saying, well, you left the t out of the first one. Okay, there's my t. Put that back in. One of the things you may notice as I increase that this is getting more polygonal, right? That there's these straight lines as opposed to curves. Well, that's because I'm not doing enough steps. The thing is not plotting every value of t. There's an awful lot of them. It's just picking this many steps. So it takes that total length from minus pi to pi, divides it into 400 pieces, and plots those points, connects the dot. If I want to smooth it out a little bit, I have to plot a few more steps here. Okay. I don't know, that just, to me, the ability to create drawings, create things by just typing in some equations is just magical. That's why I do math, so that I can draw pretty pictures. One thing that occurs to me is, what if I did, like, instead of 25, let's do 12.5. And so what I see here, where do I see it? Over here, that it only goes, it doesn't, if I was looking straight down on it, I might not notice that it doesn't line up there. Right? It seems to connect, but they're not really connected. I'm doing 12.5 loops as I go around. So maybe if I go around twice, I can get 25 loops, but now they're be overlapping with each other. So let's go from 2 pi to 2 pi, and sure enough, now it loops 25 times, but you can see the loops are crossing over each other, where before they weren't crossing over each other. And you could do all sorts of variations of, crossover 3 times, right? If we took 25 divided by 3, which would be, well, that looks funny. Oh, I'm not going around enough times, right? Now I'm going to have to go around 3 times. Let's go from minus 3 pi to plus 3 pi. And now I've got this 25 loops, but as you follow from one loop down and out the other, you skipped 2, right? It's every third one. Just phenomenal. So I can do all kinds of sorts of things with circles and I mean, essentially this looks like a donut or a torus, right? It's circles on circles, and in the XY it's a circle in one direction, and YZ it's a circle in the other direction. Let's take a different tact here. Let's go for a completely new thing. Let's go back to sine t, and instead of cos t, how about sine 2t and sine 3t. Now this, all of them are just going to oscillate back and forth between 1 and minus 1. It'll go through the origin because when t is 0, that'll be 0, 0, 0. But what does this look like? It looks like all kinds of different things depending on what orientation you have. Yeah, there's just all kinds of crazy curves you can get here by just taking some combinations of different signs. I mean, these curves just look really cool. Can I get this in motion? Come on now. There we go. This is what math is all about. Just playing with stuff, making pretty pictures, making animations that are just mind-blowing. Anyway, play. That's what I want you to do. I want you to just experiment, see what kind of curves you can come up with. It's a great way to learn. I've been doing it all my life. Every time, my dad was a high school math teacher, and every time he came home with a new calculator, a new computer that the department had bought, I would play with it. I would just experiment with things and see what I could do, and I learned an awful lot about it just because I played.